Okay, we're ready for notes 4C for the Math 4 course. And yeah, sine over cosine equals tan, just in case nobody got that one. All right, this one, I probably ought to fix this just a little bit. Because these guys, something about my graphics program, but anyway, the little a and the little b and the little c belong right there. And the idea is that there are relationships in the triangle, and I've mentioned some of these before, but here it really comes back, it hits home with a vengeance. Because the idea is that right now, I would say that little c appears to be the largest side on this triangle, which means that angle C is going to be the biggest angle. I would also say that little a appears to be the smallest side on the triangle, which means that big A is going to be the smallest angle. And there is that relationship, the largest side. That's why the hypotenuse is always the largest side of a triangle, because if you've got a 90-degree angle, nobody else is bigger. At least they better not be. So there is that relationship between an angle and the side across from it. Now, we're going to use this relationship with sines. And this is probably one of the first places where you'll use sine, cosine, and tangent outside of a right triangle, because these are not right triangles. These are anything but. But this law of sine works, and we're going to learn a similar law of cosines that actually involves a little more calculations. So I like law of sines because it's pretty easy. You set up a proportion, you cross multiply, and you there. So let's mark our diagram just so that we know where we're at. Angle A is 36 degrees, and angle B is 48. And little a, which is across from big A, is going to be 8. And so we're supposed to solve the triangle, that is to say, find all of the angles, all of the sides. So first of all, I'm going to pick the easy one first. I'm going to figure out, well, if I add those two angles and add C, they should add up to 180, which leaves me with 96 after I subtract the other two off. Now that should be helpful. Now we're going to use, I will say this, that because the only side that we know for sure is the 8, we're going to use the sine A in both finding out little b and finding out little c. We're going to say sine A over little a equals sine B over little b. And then we're going to come over here and say sine A over little a equals sine C over little c. And this is going to be two separate problems. We're going to plug in, first of all, sine A is going to be sine 36, and little a is 8. And sine B is 48 degrees, and then there's little b, which we don't know. So now we're going to cross multiply. We're going to say b times sine 36 equals 8 times sine 48. Well, if I want b by itself, I'm going to divide both sides by sine 36, which is going to look like that. And then I'm going to figure out what b is. So I go to my handy and dandy calculator, and I'm going to punch in 8 sine 48. I'm going to enter that. I'm going to get a decimal, and then I'm going to divide by sine 36. And that gives me 10.1145. I'm going to just leave it at 10. That do as the Romans, when in Rome, do as the Romans do. Everybody else is a whole number. So I'm going to leave it as 10 just because it's that close. And we'll leave it at that. All right. Now let's go chase after little c. I'm still going to use sine of 36 and little 8. But for sine of c, I'm going to say sine of 96 degrees over little c. So when I cross multiply, I get c times sine 36 equals 8 times sine 96. And then I'm going to divide both sides by sine 36. And we'll see what the calculator says. 8 sine 96. Oops. Helps if I clear my screen first. 8 sine 96. And I get a decimal for that, and then I'll divide by sine 36. And I get 13.53. Well, I would round that up to about 14. And considering that I have a 14 here and a 10 there, I'm not going to quibble, but so much if the rounding seems like it's, on a different day, I might have said 13.5 instead of 14 just because it felt more accurate. But here's where I want you to notice the game that's going on within the triangle. Who's the smallest angle? 36 degrees is the smallest angle. And the side across from it is the smallest side, 8. Who's the biggest angle? The 96. And the 14 across from him is the biggest side, 14. So, this stuff really does work that way. Now, we're going to encounter a situation in just a few minutes where sometimes we need to pay attention to these rules because they're going to help us avoid an issue about the law of sines. And right now we've been using the law of sines to mostly find sides, and that you won't get into trouble with. But when you use it to try and find angles, there's a situation coming up that we're going to talk about shortly. But in the meantime, let's get a little more practice. I have angle A is 35 degrees. Angle B is 15 this time. And little c is 5. Now, if I were to subtract from 180, I would figure out that c is 130. It's a little bigger than what we had the last time. So let's see what happens with that. And because the side that we have to work with is opposite of c, that means we're going to be using sine c over c in both of these. And we're going to use sine c to figure out what little a is and what little b is. So here we go. Sine c is sine 130 over little c, which is 5. Sine of a is sine of 35. And then little a is what we're looking for. So when I cross multiply, I get a times sine 130 equals 5 times sine 35. Now, if I want a by itself, I'm going to have to divide both sides by sine 130. And so that's what it's going to look like. And so I'm going to punch that into my calculator and figure out what my final decimal is. So I'm going to say 5 sine 35 and hit enter, get a decimal for that, then divide by sine of 130. And I got 3.745. Now, because my 5 is so small, I think I'm going to do 3.7 here because I'm dealing with a lot smaller numbers. So we'll switch over to figuring out what little b is. Sine of c is sine of 130 over little 5. Angle b is sine of 15 over little b. When I cross multiply, I get b sine 130 going one way and 5 sine 15 going the other way. Then I want to divide both sides by the sine of 130. And let's see, 5 sine 15. And that gets me a decimal. Whoops. My calculator is not behaving well. All right, 5 sine 15 decimal, and then divide by sine 130. And that gives me 1.689. I'll call it about 1.7. Now, once again, I'm going to bring that over here. Little b is 1.7. little a is 3.7. And I'll want to check, please, it's always a healthy thing to check your answers before you walk away. 15 is my smallest angle, and 1.7 is my smallest side. That's done. Check. 130 is my biggest angle, and 5 is my biggest side. Check. So if you can look at small and medium and large, then you know the medium's got to be in place. And so you're able to move on from that point. Now, here's a real world kind of problem. How do they measure distances? If the Mississippi River is like 3 or 4 or 5 miles wide at one point, how would they measure that? And this might give you a clue. How can you stand on one side of the Great Canyon, of the Grand Canyon, and measure to the other side? This gives you an idea on how it usually happens. Is that you pick 2 points on one side, and you pick 1 point on the far side that you're trying to measure toward. And my angle for A is 82 degrees, and my angle for C is 52 degrees. And I know that there's a distance of 200 feet between these two. Now, this is all on one side of the river. And you're trying to measure, what is the distance to the other side, or more specifically, what is the little C side that's across from the big C? That's what they're asking for. So I'm recognizing that the only side that I have to work with is the 200, which, wait a minute, I don't know how many degrees angle B is. So I'm going to have to back up and say, all right, 82 plus 52 plus B should add up to 180. Now, those make 134, which this is going to make 46. 134 and 1, yeah. So that should be 46. Now, I'm going to use the 46 and the 200 as my place that I'm starting from, that I know these numbers are accurate. All right, so I'm going to say sine B over little b, and then it is little c that I'm after, so I need to go sine of big C. So here we go. Sine of B would be sine of 46. Little b is 200. Sine of C would be 52. And little c is what we're looking for. So when I cross multiply, I get C times sine 46. I get 200 sine 52. And then I'm going to divide both sides by sine 46. And let's see what the calculator says on that. So we're going to say 200 sine 52. Get a decimal for that. Divide it by sine 46. And I get 219.09. I might as well just call it 219 feet. Now, does that make sense here? The 46 is across from 200. The 52 is across from 219. Yeah, it makes sense, because if the angle is a little bit bigger, then the side across should be a little bit bigger. So this does make reasonable sense. Now, at this point, everything that we've done with this has been always about finding the sides. Now, it is possible to use a law of sines to figure out how many degrees a missing angle is worth. It has occurred to me that in all of the SOHCAHTOA problems that we did the other day, not a single one of them ever asked you what the angle was worth. It was always about solving for sides. So, and I think on the quiz this weekend, it's all about the sides. But I don't need to ignore the fact that sometimes they will ask you to find the angle, and this is one of those situations. Now, first of all, we have to have a little bit of a blast from the past, side, side angle, side, all that good stuff. Hopefully your teacher taught you that there was one that we don't do. And that was either side angle or angle side. And my joke would be, don't make one of yourself. and angle side side, because they don't work. And one of the reasons that they don't work, side side angle was never one of those that we took seriously. Unless it has a right angle, then you call it HL. But the thing you have to understand about this is that when you have an angle and two sides like this, there are actually two possible ways that you could draw the triangle. If you have an angle and one side, and then it's that second or third side, that I don't know whether it comes out here or whether it goes in there. And it's what we call the ambiguous case. It's ambiguous because with the information that we are given, there are two possible outcomes here, and we don't know which one is the right one. Well, with the law of signs, we trip up against this, but there is a way that we can check, and that is that when you get the decimal for the sign of the angle, and the decimal is less than 1, then the trick is to check both the angle that you're given and its supplement. For instance, if I have my decimal for sine of theta and I run it through the calculator and it tells me that theta is 30 degrees, well, I better check 150 also. Remember, supplement adds up to 180, right? So if the calculator tells me 30, I better check the supplement too and make sure, because between the two of them, one's going to work and the other one doesn't. So we need to, we'll see this happening here. Actually, this is just the one example. I've got 2 pages that I don't need. All right, so we're going to label angle C as 35, and little a is 11, and little b is 5.4, and little c is 7.3. Now, the thing is to find angle A, given all of this information. Now, the one set that we can count on is the C's. I know what the angle is, I know what the little c is, so I know that I can say sine of C over little c. And then it's A that we're chasing after, so I'm going to say sine of A over little a. Now, let's plug in what we got. We got sine of C, which is 35, and little c turns out to be 7.3. A is the thing we don't know, and across from A is the 11. That's little a. And so we've got all the players plugged in. Now all we have to do is cross multiply. I'd say 11 times sine 35 equals 7.3 times sine of A. Now I'm trying to get A by itself, so I'm going to get rid of the 7.3 by dividing both sides by 7.3. That's going to give me sine of A. Now, when you were doing SOHCAHTOA, hopefully your teacher taught you the trick on how to find when you know what the decimal is. Because if we put all this stuff on the left side into the calculator, we're going to get a decimal. We're going to get a decimal 8.8 something. Let's go ahead and figure that out. 11 sine 35, get a decimal for that, divide 7.3. And it is 0.864, yada, yada. So if I know that my sine of A equals that, how do I turn it into A? How do I know how many degrees A is? Because when you think about it, the sine is nothing more than a fraction of opposite over hypotenuse. Well, decimal is a fraction in a way of thinking of it. But what you would do is you would go to the calculator and you would say second sine. Now, second sine, when you punch it in, is going to look like this. And normally, if we were doing a SOHCAHTOA problem where we had like the opposite is 12 and the hypotenuse is 15, then we would punch in, 12 divide 15, close the parenthesis, and whatever the answer, gave us, that's how many degrees that angle A was. Well, we could pull the same stunt here with a decimal. I've got it in my calculator. All I have to do is second sign and then second answer, and it puts the decimal right in there. Second sign, second answer, close the parenthesis, oops, close the parenthesis, and then enter. I got 59.8 and some change. Well, 59.8, you might as well say that measure angle A is 60. Now, remember the warning that they gave us, that if the sign is less than 1, oh, yes, it is, 0.864, yes, it's less than 1. That means that I better also check the supplement, whatever the other angle is that adds up to 180 degrees. So now the question becomes, which one is the right one? Well, let's try the 60 first and see what happens. If I put a 60 there, 60 and 35 is 95, taken away from 180 is going to leave me with that. Now, if I look around here, who's the smallest angle? 35. Is 7.3 the smallest side? Actually, no, it's not. No, it's not. 11 is the biggest side, but 60 is not the biggest angle. This is wrong on so many levels. So we're going to back up and say, all right, let's try this with 120. If he's 120 and he's 35, that's 155 taken away from 180. Leaves me with 25. Now, does it make sense that 11 is across from a 120-degree angle? Yeah, largest side, largest angle. 25 is my smallest angle, and 5.4 is my smallest side. So that makes sense. So what we're saying here is that that is the correct answer, and this one is not. But again, you won't know unless you know enough to check. And that is the thing with these, with the law of sines, law of cosines, is that you really kind of have to look behind yourself when you're done and make sure that the answers make sense within the triangles, that the side and the angle that's across from it really are small and small, or large and large. If you figure out who the smalls are and who the larges are, the medium is going to, fend for itself. You're not going to have to worry about it. All right, so that is what it's like trying to solve problems with the law of sines. We'll do this. We'll have the worksheet. And then the next section, we'll actually get into law of cosines, which is a little more calculation heavy. This one is really simpler and lighter, and I enjoy it so much more. But we will look at law of cosines next time. So.